Hello everyone. Today we are going to do a question that most of the time bothers the students, and it's although really easy question, but still some students get panicked by the just like the look of the question. Some of them don't even know how to do it. So I can give you an idea today that would provide you very easy understanding of this particular question. This question is from the paper 9700, variant is 12, October November session 2022, question number 1. So let's begin. This question says the diagram shows a stage micrometer with divisions 0.10 mm apart. So one division is 0.10 mm viewed through an eyepiece containing a graticule. So this is basically the vision in the eyepiece, and you know very well that this is a stage micrometer, and this one is the eyepiece graticule. Eyepiece graticule. So this is a particular way of naming them because you know that in chapter number 1 we have a whole practice, we have a whole topic that how can we measure different thing in the light microscope. So but that particular concept is related to measuring the size of the objects, measuring the size of the specimens. But this question is related to field of view or FOV. FOV. And we need to focus on FOV, not the size of any particular specimen. So we are going to measure the FOV with the help of the formula area of the circle is equal to pi r square, and pi is equal to 3.142. A student calculated the area of the field of view of the microscope using information provided and a value for pi of 3.142, which answer has been rounded correctly to an appropriate number of significant figures. We know very well that significant figures are always come with the power of 10. Like you have your value, let's say x point 0 into 10 raised to power n. This is the way to write the significant figures. So now we have a particular data. We are going to work on it. First of all, let's let's see that what are the calibrations? What are the calibrations of uh, EPG, eyepiece graticule, and stage micrometer? So obviously we need to find out the radius here. So if we need to find out the radius, we know very well that if this is the diameter, if this is the diameter, then this one is the radius. The radius is half of the diameter, obviously. So this is the diameter, and this one is the radius. So it means that we are not going to consider the coinciding of 90 with this scale, because we don't need to coincide them. We need to coincide only the values which are exactly at the point of the radius. So how are we going to get the radius? To get the value of the radius, first of all, we need to calibrate it. So we'll calibrate the middle value with the coinciding value of the eyepiece graticule, middle value of stage micrometer, and eyepiece graticule value. So the stage micrometer is having the value of zero point 0.1 here. Just look at this. This is zero point 0.1. These are the distance of 0.1. So this value would be 0.1, and it is uh, calibrating. It is being calibrated with the eyepiece reticule, and the point at which it is calibrating, it is getting calibrated with the eyepiece reticule is 50. So, but if you know that the initial coinciding point and this coinciding point, they're coinciding starting from 10 and ending at 50. So we cannot put 50 over here because we have to calculate it right from the first coinciding point till this coinciding point. So this would be 50 minus 10, 40, because it's the coinciding is starting from 10 and ending in 50, so it would be 40. So let's say it means that 0.1 is equal to 40. Now we need to know one division. This is for 0.1. This is for the value that 0.1 of the stage micrometer, 0.1 of the stage micrometer equals to 40 divisions on eyepiece reticule. So if we want to know that how much, what would be the value of one division of eyepiece reticule, we got this answer 40 for 40 divisions of eyepiece reticule. We need to know that one division of eyepiece reticule would be equal to, what would they be equal to? So we would be, if we want to know that one division of EPG is going to be 0.1 divided by 40, and this one would be 0.0025. You can do this for on your calculators. You can confirm this. So 0.1 divided by 40, it's going to be 0.0025. But remember that the values on the stage micrometer are in millimeters. So this is in millimeters, 0.1 millimeter. So 0.1 over 40, 0.0025, it's in millimeters. So obviously, in microscope, the unit that we always use is the micrometer. So what do we do? 1000 into 0.0025. 0.0025 millimeter. The answer would be 2.5 micrometer now. Now this is uh, one division, one division of eyepiece reticule. What does it mean? All single scale, all scales either larger or smaller, all the scales are equal to 2.5 micrometers. All the scales. This is exactly according to the book of Cambridge A levels. So one division of eyepiece reticule is equal to 2.5 micrometer. 2.5 micrometer. So now we need to know the radius. Obviously, the radius is equal to diameter divided by 2, which means half the diameter. So if you see the field of view, it's starting from 0 and ending in 50 according to radius. I'm not saying the diameter would go ahead. The diameter would go ahead, no doubt, but we just need to know the radius. So according to the field of view, the half field of view is the half field of view is from 0 to 50. If we were to calculate the diameter, then it would be full field of view. But now we need to know the half field of view as we need to as we need to calculate the radius. So uh, the radius, if you focus, there are 50 values. If you radius is equal to 50, radius is equal to 50 values of eyepiece reticule. 50 values of eyepiece reticule. So it means that if you want to find out the radius, then each value 50. Each value, what did we decide? Each value is 2.5 micrometer. So if it is 50 values of EPG, so one value or one division of EPG is equal to 2.5. So 50 values would be 2.5 into 50. It would be 125. 50 into 2.5, 125. This is your radius now. But this radius is in micrometer, right? This radius is in micrometers. Okay. So you have got 125 micrometer. Now let's find out area is equal to pi r square. Area. Area equals pi r square. R is this 125 micrometer. So 3.142 into 125 micrometer whole square. So let's find it out. 125 whole square 3.142 into multiplied with 15,625 micrometers square. I guess you would not be surprised by micrometer square because it was 125 micrometer. So once we took the square, it would be micrometer square now. Now multiply this 3.142 into 15,625. The value is coming 49093.75. Okay, micrometer square. So we need to convert it into the standard value. The standard value is the original value is 49093.75. Now this decimal for standard value, you have to put this decimal to this position. So you know that once we try to write down the standard value, we need to move the decimal either to the left or to the right. So we are moving it to the left. So once we move it to the left, it's going to be 4.9 in sorry, yeah, 4.9 4.9093 into 10 raised to power. How many positions the decimal moved? 1, 2, 3, 4. 4 micrometer square. It looks like this is the answer. But remember that we need to shorten it. They are saying has been rounded correctly to an appropriate number of significant figures. Now we would round it off because in as a standard value we must know that the 4.9093 cannot be is not short enough. We need to shorten it to the significant figure, but the problem is we cannot make this 4 into 5. It would not be a significant figure. In the beginning I told you x point 0, this must be there in the significant figure. So instead of converting this 4 into 5, we would just convert this 0 into 1. So 4.91 into 10 raised to power 4 micrometer square. So this is your answer, and the answer is D. The answer is D. So for more content, please follow my channel. I have many recorded lectures there. I hope you got it. If you have any question, please let me know. Thank you very much.